Mars, the untold story of humanity's greatest planetary quest. In the modern history of space exploration, no planet has captivated the human imagination more than Mars. Cold, arid, and coated in reddish dust, it was long observed as a distant, possibly lifeless world. But beneath its silence, scientists saw potential. What if Mars once had oceans? What if it still harbors signs of life? For over 6 decades, NASA has sent orbiters, landers, and rovers to the Red Planet, each mission with a clear purpose: to understand what Mars was, what it is now, and what it might mean for the story of life itself. Pushing boundaries of technology, a global effort. Across time, each mission has pushed the boundaries of technology. It has taken decades of engineering, precision calculations, and mid-flight corrections just to reach the Martian surface. Each successful landing has been a scientific and operational triumph. And with each new data point, Mars has transformed from a vague red into a real, physical world, one with canyons, dust storms, ice caps, and a geological history still unfolding. This is the legacy of over 50 years of exploration, a journey from blurry black and white photos to molecular analysis, from failed flybys to helicopters flying above Martian soil. This is everything NASA has discovered about Mars so far. For generations, Mars had been imagined as a world of canals, vegetation, or even intelligent life. But the images revealed a barren, cratered landscape, eerily similar to Earth's moon. It was dry, desolate, and lifeless, at least on the surface. Still, NASA pressed forward. In 1969, Mariner 6 and Mariner 7 flew even closer, capturing over 200 images. They showed polar frost caps, vast impact zones, and unusual terrain formations. The idea of Mars as a temperate, Earth-like planet quickly faded, replaced by a more complicated picture: a cold desert world with an ancient, possibly violent history. A cold desert world. Not what they expected. Then came Mariner 9. Launched in 1971, it became the first spacecraft to orbit another planet. When it arrived, Mars was cloaked in a massive, global dust storm. For weeks, the surface was invisible. But when the storm lifted, Mariner 9 unveiled something astonishing. Towering volcanoes, enormous canyons, dried riverbeds, features that hinted at a planet shaped not only by wind and meteor impacts, but by flowing water and internal geology. Mariner 9 mapped over 80% of the Martian surface. It discovered Olympus Mons, the tallest volcano in the solar system. It revealed Valles Marineris, a canyon stretching over 4,000 kilometers, more than 10 times the length of the Grand Canyon. Mars was no longer just a mystery. It became a world with structure, scars, and depth. A world that wasn't simply dead, but ancient, dynamic, and possibly once alive. The era of Martian exploration had truly and irreversibly begun. The Viking program consisted of 2 spacecraft, Viking 1 and Viking 2, each made up of an orbiter and a stationary lander. They were among the most advanced and ambitious interplanetary missions ever attempted at the time, designed not only to study Mars from orbit, but to physically interact with its surface. Their goal was clear: to analyze Martian soil, examine the atmosphere, and search for signs of life. On July 20th, 1976, Viking 1 made history by becoming the first spacecraft to land on Mars and complete its mission. Its counterpart, Viking 2, touched down less than 2 months later on September 3rd. Together, they transmitted the first high-resolution, full-color photographs from the Martian surface. The landscape revealed was dusty, rocky, and windswept under a hazy, rust-colored sky. Beneath the visuals, though, the scientific payload was at work. Each lander conducted a suite of biology experiments aimed at detecting microbial life. One of these, the labeled release experiment, yielded data that sparked intense debate. Was it evidence of life, or merely chemical reactions caused by the soil's unusual properties? Ultimately, most scientists agreed on the latter, that the reaction likely had a non-biological explanation. Still, the Viking landers gathered a wide array of atmospheric and environmental data. They confirmed that Mars has a thin atmosphere composed mostly of carbon dioxide, with surface pressures less than 1% of Earth's. They recorded temperature fluctuations, frost formations, and shifting wind patterns. The orbiters, meanwhile, mapped vast portions of the planet in detail, discovering dormant volcanoes, channels carved by ancient water, and vast canyon systems. Beyond expectations, a lasting legacy. Originally intended to operate for just 90 days, the Viking landers far exceeded expectations. Viking 1 continued sending data until 1982, over 6 years of continuous surface science. Though they did not find life, Viking transformed our understanding of Mars and set the stage for every mission that followed. It proved that complex robotic science on another planet was possible, reliable, and invaluable. Viking was not the end of the search for life, but the beginning of a much deeper quest. Throughout the 1980s and early 1990s, NASA faced budget constraints, shifting political priorities, and increasing technical challenges. No new missions reached the surface of Mars. The Viking landers had far exceeded expectations, but the lack of definitive evidence for life had dulled public interest and reduced congressional funding. Silence on Mars. A pause in the journey. Several mission proposals were canceled, postponed, or restructured. Meanwhile, the Viking orbiters gradually went dark, and Mars, once the symbol of planetary ambition, faded from the spotlight. In 1992, NASA made a bold attempt to return with the Mars Observer. It was a highly advanced orbiter designed to produce detailed maps of the Martian surface and atmosphere. But just 3 days before it was scheduled to enter orbit, all communication was lost. The spacecraft vanished without a trace. For nearly 20 years, Mars sent no new signals back to Earth. Scientists were left with questions, outdated images, and growing frustration. Yet in the background, a new generation of researchers and engineers quietly planned their return. A new era was coming, one forged in patience, caution, and the hard-earned lessons of failure. On July 4th, 1997, Independence Day in the United States, the Mars Pathfinder mission successfully landed on the Red Planet. It wasn't just a lander. It carried a small, 6-wheeled robot named Sojourner, the first rover ever to operate on another planet. Pathfinder was a technology demonstration mission. Its goal was to test new landing methods, surface mobility, and cost-effective spacecraft design. It used an airbag landing system, bouncing down onto the Martian surface before coming to rest in a region called Ares Vallis, a rocky plain shaped by ancient floods. Sojourner, no larger than a microwave oven, was designed to last just 1 week. Instead, it survived for nearly 3 months, traveling over 100 meters across the surface. It took detailed images of Martian rocks, analyzed soil composition, and provided critical engineering data on mobility, communication, and durability. One of its key discoveries was evidence of past water flow. The rocks in Ares Vallis appeared rounded and eroded, shaped by rushing water. This supported the theory that Mars had once experienced surface liquid water, a vital ingredient for life. A viral scientific event, inspiring a new generation. But beyond the science, Pathfinder sparked something else: public fascination. Daily updates, images, and videos were posted online, reaching millions of people worldwide. It became one of the first truly viral scientific events of the internet era. Pathfinder and Sojourner didn't just prove that NASA could return to Mars. They showed that exploration could be faster, cheaper, and still deliver powerful results. The mission reignited global interest in Mars, inspired a new generation of engineers, and laid the foundation for the more ambitious rover programs that would soon follow. Odyssey's mission was ambitious. It aimed to map surface composition, measure radiation levels, identify minerals, and search for signs of buried water ice. Unlike earlier missions focused on specific landing zones, Odyssey's scope was the entire planet. After arriving in October 2001, the spacecraft used a technique called aerobraking, skimming the upper atmosphere to slow down and enter a stable orbit. Once in place, it deployed an array of instruments, including a gamma-ray spectrometer, a neutron detector, and an infrared camera, to begin its survey. Within months, Odyssey made one of the most important discoveries in Mars exploration. By analyzing hydrogen concentrations near the poles, it detected vast quantities of subsurface water ice, hidden just beneath the dusty soil. This finding transformed scientific thinking. Water still existed on Mars, not in ancient riverbeds, but locked in ice today. Odyssey also studied cosmic and solar radiation levels, providing essential data for future human missions. Its results warned of high exposure risks and helped mission planners develop safer strategies for astronauts. The invisible bridge, connecting Earth to Mars. Perhaps less visible, but just as vital, was its role as a communications relay. Odyssey transmitted data between Earth and every major surface mission, including Spirit, Opportunity, Curiosity, and Perseverance. It became the invisible bridge connecting Earth to its robotic explorers. Odyssey's thermal maps revealed seasonal changes, mineral compositions, and even frost cycles of carbon dioxide. Its long-term data turned isolated findings into global patterns, helping scientists understand the Martian climate and geology. It's also a record setter. With more than 2 decades in orbit, Mars Odyssey is the longest operating spacecraft ever sent to another planet. Still active today, it continues to shape research and enable missions. Odyssey didn't land. It didn't drill or dig. But it changed the way we view Mars, not as a collection of sites, but as a world. It made Mars visible, and it made Mars make sense. Spirit and Opportunity were part of the Mars Exploration Rover mission. Their objective was clear: to explore the Martian surface, analyze rocks and soil, and search for signs that water had once existed on the red planet. Both spacecraft used a parachute and airbag system for landing, an upgraded version of the technique proven by Pathfinder. Spirit touched down in Gusev Crater on January 4, 2004. 3 weeks later, Opportunity landed in Meridiani Planum, on the opposite side of the planet. Beyond expectations again, a testament to endurance. Each rover was designed for a 90-sol mission, roughly 3 months. But what followed far exceeded all expectations. Spirit operated for over 6 years. Opportunity functioned for nearly 15. These are not fast vehicles. They crawled slowly across the surface, just meters per day, but they revealed a world rich with geological complexity. Spirit discovered signs of past hydrothermal activity and acidic environments. It climbed hills, captured panoramic views, and became stuck in soft terrain in 2009, eventually ceasing contact. Opportunity became the mission's enduring symbol. It discovered hematite spherules, or blueberries, formed in wet conditions. It explored the interiors of craters, studied layered rock formations, and provided conclusive evidence that Mars once had water, not just in vapor, but in pools and seas. It survived dust storms, freezing winters, and even a sand trap. In 2018, a massive global dust storm blocked out sunlight and cut power to the rover. NASA sent signals for months. Eventually, the mission was declared complete. Its final words, paraphrased by engineers, became iconic. "My battery is low, and it's getting dark." But their story didn't end there. Spirit and Opportunity reshaped how NASA approached surface missions. They proved that long-duration, mobile exploration was not only possible, it was transformative. They helped turn Mars from a distant curiosity into a dynamic, accessible world. They gave humanity its first long-term presence on another planet. And in doing so, they inspired a new era of rovers. and a new generation of explorers. The Phoenix Mars lander was the first mission to explore the Martian Arctic, targeting a region near the planet's North Pole. Its objective was to investigate the history of water in the region and assess whether the environment could ever have supported microbial life. Phoenix was built using components from canceled missions, but its science was entirely original. It carried a robotic arm designed to dig trenches and retrieve soil and ice samples from beneath the surface, a first for any Martian lander. On May 25, 2008, Phoenix successfully landed on Mars. It began work almost immediately, using its robotic scoop to dig into the soil and deposit samples into tiny onboard ovens. There, the material was slowly heated, releasing gases that were analyzed to determine chemical composition. The results were extraordinary. Phoenix confirmed the presence of pure water ice just a few centimeters below the surface. It demonstrated that water is not just ancient on Mars. It's still present and still potentially accessible. It also observed daily weather patterns, thin clouds, temperature swings, and even snowfall from high-altitude ice crystal clouds, a first in Martian meteorology. The Martian Arctic secret, frozen, waiting to be found. Phoenix was not built to survive a full Martian year. As winter approached and sunlight diminished, the lander's solar panels could no longer generate power. Communication ceased after 5 months. Yet in that short time, Phoenix accomplished all of its primary objectives. It expanded our knowledge of Martian water, climate, and chemistry. Phoenix didn't drive across Mars, but it revealed what was hidden beneath, silently frozen, just waiting to be found. To answer it, NASA launched the most advanced planetary rover in history. Curiosity, part of the Mars Science Laboratory mission, was unlike any machine sent before. About the size of a small SUV, it carried 10 scientific instruments, cameras, spectrometers, drills, weather sensors, and its own mobile chemistry lab. Its nuclear power source allowed year-round operation, immune to dust storms, shadows, and Martian winters. On August 6, 2012, Curiosity made a dramatic landing inside Gale Crater, a 150-kilometer wide depression with a central mountain, Mount Sharp. The landing involved a revolutionary method, the Sky Crane, a rocket-powered platform that gently lowered the rover by cables. The maneuver worked flawlessly and marked a new era in planetary exploration. Gale Crater was chosen because of its rich, layered history. Mount Sharp, rising 5 kilometers high, preserved Martian sediment in layers, ancient environments stacked like pages in a geological archive. Curiosity's goal was not to find life directly, but to determine if Mars had once supported the conditions for life. The answer came quickly. Curiosity discovered rounded pebbles and riverbed features, shaped by flowing water. It drilled into clay minerals, finding strong evidence that Gale Crater once hosted a freshwater lake, with neutral pH, essential minerals, and a stable environment potentially suitable for microbes. Later, the rover identified organic molecules, carbon-based compounds that are the building blocks of life. While not direct evidence of biology, their presence raised new possibilities about Mars' past chemistry. One of the mission's biggest surprises was the detection of methane in the atmosphere. On Earth, methane often comes from biological sources. On Mars, its origin remains a mystery, and its seasonal variation adds to the intrigue. Curiosity also measured radiation levels, helping scientists plan for future human exploration. Its data showed the need for shielding and safe habitat designs, making it vital for long-term mission planning. The rover studied weather patterns, dust activity, and atmospheric shifts. It captured vast panoramas, close-ups of strange rock formations, and time-lapse movies of passing clouds and shadows. A new understanding, redefining the planet. Over the years, Curiosity climbed the slopes of Mount Sharp layer by layer. Each stratum revealed new insights into Mars' climate history, transitions from wet periods to arid deserts. As of today, Curiosity has traveled more than 30 kilometers, climbed over 600 vertical meters, and drilled into dozens of rock targets. It has returned hundreds of thousands of images and continues to operate over a decade later. But its greatest achievement isn't a single discovery. It's a new understanding. Curiosity proved that Mars was once habitable. It showed that complex, long-term robotic missions can transform how we study entire planets. And it reminded us that exploration isn't always about answers. It's about building the questions. Curiosity wasn't the first rover, but it was the first to find the habitable Mars. It redefined our mission, and it redefined the planet. Launched in 2018, the InSight lander was built to investigate the planet's deep interior, its crust, mantle, and core. It wasn't looking for water or life. It was asking a more fundamental question: how did rocky planets form? InSight deployed a super-sensitive seismometer to detect Marsquakes, faint tremors caused by tectonic shifts or meteor impacts. For the first time, scientists could listen to Mars rumble and shake. The data revealed a crust thinner than expected and a larger, partially liquid core, a finding that reshaped planetary models. InSight also carried a heat probe designed to burrow deep and measure internal heat flow. But the Martian soil was tougher than expected, and the probe failed to reach its target depth. Despite that, InSight succeeded in its core mission. It recorded over 1,000 Marsquakes, including some triggered by massive meteorite strikes that revealed underground ice. And it proved Mars is still geologically active, not lifeless but slowly evolving. InSight didn't move, but it listened deeply, and through that silence, it gave Mars a voice. Together, they became Perseverance and Ingenuity, the most advanced and daring explorers ever sent to Mars. Perseverance touched down in Jezero crater on February 18, 2021. This 45-kilometer-wide basin once held a lake and river delta, making it one of the most promising places to search for past microbial life on Mars. Perseverance's primary objectives: search for signs of ancient life, collect rock and soil samples, and pave the way for human exploration. The rover is equipped with 23 cameras, a robotic arm, a rock drill, spectrometers, microphones, and an instrument that can turn carbon dioxide into oxygen, a crucial technology for future astronauts. Perseverance began drilling and storing core samples of Martian rock in titanium tubes, each sealed and preserved for eventual return to Earth by a future mission. It's a groundbreaking step. These will be the first Mars samples ever brought back for analysis with the full power of Earth-based laboratories. As it traversed the crater, the rover examined sediment layers that formed in watery environments. It analyzed ancient mudstone, searched for biosignatures, and studied the chemical makeup of rocks shaped by rivers and lakes. A first in spaceflight history, beyond imagination. Then came a first in the history of spaceflight. Attached beneath Perseverance was a small, experimental helicopter, Ingenuity. It weighed less than 2 kilograms, with carbon fiber blades spinning 4 times faster than those on Earth. It was meant for a short tech demo, just 5 flights. But on April 19, 2021, history was made. Ingenuity became the first aircraft to fly on another planet. It rose 3 meters, hovered for 39 seconds, and landed, a quiet but revolutionary moment. For the first time, humans had taken flight beyond Earth. That was just the beginning. Ingenuity flew again and again. It became a scout, helping Perseverance avoid hazards and map safe paths. By late 2023, it had completed over 60 flights, proving that powered flight on Mars was not only possible, it was useful. Together, the duo explored Jezero's ancient delta system. They documented layered deposits, measured atmospheric conditions, and even captured the sounds of Mars: wind gusts, the crackle of lasers, the wheels crunching over gravel. Perseverance also tested MOXIE, a small device that converted Mars carbon dioxide into breathable oxygen. This technology may someday support astronauts and provide fuel for return trips. But the biggest prize? The rock core's perseverance has been storing. They could contain fossilized microbial life, preserved in clay minerals for billions of years. Their return to Earth, planned for the early 2030s, could mark the single greatest scientific discovery of the century. Meanwhile, Ingenuity opened skies. Its success has inspired future missions, including rotorcraft landers on other worlds, like Saturn's moon Titan. Perseverance and Ingenuity are still active, still exploring, still rewriting the rules of what robots can do. Mars is no longer just a distant red dot in the sky. It's a place we now explore in detail, driving, drilling, flying, and preparing for the moment when the first humans set foot on alien soil. The search for life is no longer theoretical. It's rolling across the surface, flying over ridges, and drilling into stone. One bold mission, unfolding in real time. But before footsteps comes the next great leap, bringing Mars to Earth. NASA, in collaboration with the European Space Agency, is leading the most ambitious planetary science mission in history, the Mars Sample Return Campaign. Perseverance is already collecting samples. The next phase? Launching a retrieval rover to pick up those sealed titanium tubes and deliver them to a Mars ascent vehicle, the first rocket to launch from the surface of another planet. That rocket will carry the samples into orbit, where they'll be captured by an ESA orbiter and flown back to Earth, a journey of millions of kilometers, culminating in a return by the early 2030s. These samples could reveal microscopic fossils, ancient organic molecules, or the geologic history of a world that once had water. It could finally answer one of humanity's oldest questions. Are we alone in the universe? Only the beginning, the next great adventure. But even that is only the beginning. NASA's Artemis program is returning astronauts to the moon, not just to visit, but to learn how to live on another world. The moon will serve as a training ground for habitats, resource extraction, space travel, and survival. These technologies will be essential for Mars. A human mission to Mars will take months to get there and years to complete. Astronauts will need radiation shielding, closed-loop life support systems, and the ability to create oxygen, water, and fuel from Martian resources. They'll face isolation, gravity changes, and psychological challenges, but they will go. And when they do, it will be the greatest journey ever taken. Prototypes are in development. Mission architectures are being debated. International partnerships are forming. And humanity is preparing for the first boots on the red planet. We've sent orbiters, landers, rovers, and even a helicopter. We've studied Mars from every angle. But the next chapter will be human. Mars is waiting, and we are on our way.